I believe this is the first proof that I've asked you to do. But don't worry, I'm here to help. So if you have positive terms and the original AN series converges, so adds up to a finite amount, then when you square all of the terms, it's also going to converge or add up to a finite amount. All right, so for the proof, we begin with a little bit of an explanation. Since the AN series converges, that means that the numbers themselves in the list have to get smaller and smaller and smaller. So that means that the limit as n goes to infinity of the AN has to become 0. So if the numbers are going to add up to a finite amount, eventually they have to be very small. So basically that would be, here's a number 1, number 2, number 3, number 4, etc. And at the beginning, it doesn't really matter how big the terms are. They could be up here at 7, maybe this one is at 5, something like that. But since the limit is equal to 0, eventually they're going to have to drop down and they're going to have to stay really low. Since that's true, they're going to have to drop down. That means there's going to become a time when you can put a nice purple, pink, whatever color that is, line, and say there must be a time when I put a line right here at 1, and then after that, they're all going to be under 1. So it just so happens to be right here at the number 3, but we could just say in general there's going to be some number m where beyond that all of the little dots are going to be under 1. Okay, so this means that there is some point m or some number n so that all of the ANs are going to be less than 1 beyond that point. For all of the n's going past m, and it could be bigger than or equal to, or just bigger, that's not really that important. But anyway, all of these ANs are going to be less than 1. And just as a little pop-up ad, let me show you how to write this in math. So this means that there is a number m. That's a lot of words to have to write down. See, I even have a hard time saying it, much less writing it all. So in math, you would say there exists an m. So the backwards e takes care of this, means that there is a number m. And then saying so that takes a lot of work. So you just go like this and put a little lowercase backward e, so that an is less than 1. And then to write 4 takes a lot, so you just put a straight line and then write it like this. And then that is the sentence translated into math. Okay, that little pop-up ad is done. Now back to our regular show. All right, since an is less than 1, and also at the beginning it says the a's are positive, so that means that I can multiply this inequality on both sides. Let me just rewrite it so I have a little more room. So I can take this inequality and I can multiply on both sides by an itself. And since an is positive, that's not going to change the direction of the inequality. And then that means on the left side we have an squared is smaller than an. And then that means that the sum of the an squares are going to be smaller than the sum of the an's. And since this one converges, if this one is smaller than it, it also converges. Therefore, an squared, I forgot to put my summation, sigma, sigma, sigma. So the sum of the an squares also converges. Oops, that was a sloppy S, sorry. And then at the end of the proof, you write QED. that which was to be demonstrated. But just say it in Latin.